Hello and welcome back to MacroLearning organic chemistry part. Okay, so this is where we left off from the last question about alkane nomenclature, the IUPAC naming of alkanes. So we do have these three structures that we have to name. So let's just go ahead and start with the first one. So again, we have to pick the main chain, pick the substituents, and then number the substituents to make up for the name, and then we're done. So where's the main chain for this molecule here? I actually see more than one possibility. Actually, I can see three possibilities for the main chain. I hope you can see that too. Let me make copies of the structure. Okay, here we go. So to me, the main chain could be either this more straightforward one, a 7-carbon main chain, or it may be like this, still a 7-carbon main chain, right? And what's the third possibility here? Right? Again, also a 7-carbon chain. So it's going to be a heptane. That's what we call 7-carbon alkane. It's something heptane. But which one is the correct main chain? Now the rule that comes into play here is that the one that has got the most branches is the correct main chain. So let's try to find the branches for each main chain. Right? 4 branches, 4 substituents. This one, how many substituents? 1, 2, 3. This one, only 2 of them. 2, right? So 4 substituents, 3 substituents, 2 substituents. So this one wins. Okay. So again, the rule is that the main chain that has the highest number of substituents or branches is the right main chain. Let me go ahead and erase this real quick. Okay, there. Let's get rid of the structures so that we can continue. Okay, so it's a heptane again. That's what we call a 7-carbon chain. And substituents are 3 methyl groups and a propyl group. Propyl group is what we call a 3-carbon substituent. Okay, so the numbering goes like from the right hand side again. Why? Because that way we can give the lowest possible number to the first substituent along the chain, which is carbon number 2 for these 2 methyls. That's why numbering goes from the right. I mean, starts from the right. So the carbon number is going to be 2 for these 2 methyls, 4 for this propyl, and 5 for this methyl. Okay, so it's gonna be, just 1 second, it's 2, 2, 5, and then what? 3 methyl groups. What do we call it? It's a tri-methyl. Tri standing for 3 of them. 3 same substituents on the chain. Trimethyl, and then 4 propyl, right? Propyl group is on the 4th fourth carbon, 4 propyl heptane, one word. Okay, 2 to 5 trimethyl 4 propyl heptane. Now, are we in the same order alphabetically? Yes, we are, because methyl is M, propyl is P, so methyl has got higher priority than propyl. But remember, the alphabetical order doesn't have anything to do with the numbering, right? Because these won't change no matter what group you have here. It's not dependent on the alphabetical. The alphabetical only determines whether this or this will go in front of the other one in the name. Okay? I hope you get the point here. All right, very good. Next one. Okay, now this is one of the simplified structures as opposed to the full regular structures. I would make sure that you know how to convert those two back and forth, because you are going to see simplified structures like this a whole lot, over and over again in the organic chemistry class or textbook. Okay, anyway, so let's pick the main chain for this molecule, which is pretty straightforward, I think. It's just gonna be this guy here. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 carbon chain. The name for it is undecane. Undecane. Right. So it's a substituted undecane. And where are the substituents? It's here. Methyl, methyl, ethyl, right? Now, when it comes to numbering, which side do we start with? Number 1. We start from the left-hand side, because again, this way we see the first substituent on the least numbered carbon or lowest numbered carbon, which is 3. Otherwise, the first substituent will be on the 4th carbon, and that's not favored. So this methyl is on number 3, 4, 5, 6. That's the number for this methyl group. 6, 7, 8 for the ethyl group. And there we are. It's 8 ethyl. Ethyl goes in front because alphabetically it's got a higher priority than methyl again. So 8 ethyl. Now what do we call 2 methyl groups? We put them together. 3, 6 with the prefix di, right? Dimethyl. Undecane. 8 ethyl, 3, 6 dimethyl, undecane. All right. Okay, last one, almost there. Again, the simplified structure. Let's go ahead and pick the main chain. Again, pretty straightforward. Here, right? Now, if you wonder why is it not this? Well, you can do it like this. Except that it's not going to make any difference. You're still going to have this exactly same main chain with the exact same substituents. So either way, doesn't make any difference whatsoever. So let's keep it like this and try to find the substituents, which again is pretty straightforward. We have the ethyl group here and the methyl group here, right? So about the numbering, pretty obviously we're starting numbering on this side and go 1, 2, 3. So both methyl group and ethyl group are on the carbon number 3, right? They're on the same carbon. So that's it. It's going to be, oh, I'm sorry, I forgot the main chain. What do we call the main chain? How many carbons? 1, 2, 3, 4, 5, 6, 7. So again, it's a heptane. Heptane. 1, 2, 3, 4, 5, 6, 7. Yeah. 7 carbon main chain heptane. So it's a 3 ethyl, 3 methyl. Ethyl goes in front, again, alphabetically. So 3 ethyl, 3 methyl. Doesn't matter if they're on the same carbon, we still call them like this. Heptane. 3 ethyl, 3 methyl heptane. That's it. Okay, thank you very much. Please subscribe to my channel or visit MacroLearning.com. And if you have any questions or any comments about my examples and problems and solutions, please do not hesitate to either call me or drop me a line. And again, thank you very much. See you next time.